Hello everyone, and a very big, happy, and a very proud Happy Republic Day to everyone here in this classroom. So a big salute to all my heroes here in this classroom. मेरे बच्चा लोग. So once again, hi, good evening. How are you all doing? This is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya. As you all know, it's a very special moment, right? It's a very special day for all the Indians out here, and we are so proud because here we are on our Republic Day, right? Which is on Jan 26th. So, what we are going to do something special. You'll be asking, sir, are we going to do something special in today's class also? Yes, obviously. In this chapter of modern physics, we are going to be talking about one of the important topic in today's class, okay, which is the Einstein's photoelectric equation. It is very important. Understanding the concept is very important, and by using this concept, doing as many numerical questions as possible is also very important, and that is what is exactly we are going to do, because this is the day for victory for all the hardships that is being done by all our great leaders. So obviously we are also going to learn some hard topics in today's class, and we're going to make it super easy. So bacha log, tell me, how are you all doing in this very amazing day, and how much excited you all are in this amazing Republic Day? Everyone, Simran, hi. Sapna, hi. Republic Day, hi. Sanskar, Dheeraj, Jai Shri Ram, Shraddha, hi. Hello. Everyone is with full of fire in their heart. Aishwarya, good evening. Good evening. Shraddha, happy Republic Day. Thank you. Okay, happy Republic Day to everyone here once again. Hi, Amin. Hello, Sana. Hi, good evening. Sanskar, happy Republic Day to everyone here. So, sab acha kar raha hai na? Everyone is with full of josh and with full of energy, right? Like all the leaders that fought for our freedom and for making the Constitution of India, right? Okay. देख ले, if you're seeing me for the very first time, and a bit of introduction about myself is what you can see it on the screen, right? What is not written on the screen is, right, I'm not so good with the language of Hindi because I'm from Kerala, right? And obviously I'm learning the language of Hindi. It is improving in a very fast pace, fine, but still I'm not in a position to explain all the concepts of physics in Hindi. So what we'll do, we'll be doing all the conceptual explanations and discussions in English itself, but छोटी छोटी बातें हिंदी में होती रहती है. Fine. Okay, moving on. Now I'm going to show you the schedule for what we are going to do in today's this particular week. ठीक है? So here we are on 26th Jan, where we'll be having the modern physics. We'll be talking about dual natures. Okay, as I have told you. Now at 10 p.m. we have one more session. मेरा बच्चा लोग देख ले. A Republic Day special, a special motivational session, right? It will be there for half an hour. I'm expecting every one of you to be present for the session at 10 p.m. And next class will be on Friday at 8 p.m. What is it? Which one is it? Dekh le. So it is a mega Mendy quiz by combining all the chapters that we have completed till now, such as EM waves, ray optics, and wave optics. All these chapters combined, we are going to be having a mega Mendy quiz. Don't miss it. Fine. Okay. हम जा रहे हैं बच्चा लोग. देख ले, Telegram group channel here we have, right? In this Telegram channel, all the updates about our YouTube channel is being given. Don't miss your opportunity. The link is given here and also in the description if you want to be a part of the Telegram channel. We all are expecting. Jaldi aa jao chalo. Now, Bugs Bounty, what it is? It's an amazing program which can help you to get so much of prizes. What do you all have to do? Very simple. Go to the description. There you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, है ना बच्चा लोग, बहुत सारा prices आ जाएगा आप लोगों को. Okay, you'll get so much of prices. So don't miss your opportunity. ठीक है? So start checking for what all the inappropriate content, है ना? ठीक है. Now, if you haven't been a part of this Unacademy Combat scholarship test, what should I tell you? Okay, you guys are missing a lot much of benefits from Unacademy, so don't miss your opportunity. Shall I tell you what all you have missed till now and what you don't want to miss afterwards this, right? Now, let's say you are one among the first 3 ranks. What are you going to get? Is it some certificates where the Unacademy is written? No. We are going to give you gold medal for the first rank. Wow. Second rank, silver medal, and for the rank 3, bronze medal mil jayega bachcha log. Is it some medals and certificates? Gold medal itself is so awesome, right? No. We haven't completed. For the first 3 ranks, 1 year of Unacademy plus subscription is given free. Matlab, you can be a part of Unacademy family. Others also scholarships are given for being a part of the Unacademy family. So what are you waiting for, mere bachalu? Jaldi come and join. You'll be like, sir, if we want to be a part of the scholarship test, do we need to be a plus subscriber or an iconic subscriber? Which we need. You can come and enroll for this scholarship test, and it is totally free, mera bachalo. The code that you have to use is AMB10. Use it and enroll for this. ठीक है? बहुत simple है. So I'm expecting every one of you. Moving on. Now, before we start with the classes, I need to give you a small talk on what are the amazing features of Unacademy. So before that, I want every one of you to share the class to all your friends. Those who have, tell me how many of you have shared the class. Those who haven't, this is the time. Share the class to all your friends and tell Bhaiya has started that amazing topic of dual nature from modern physics. Those who haven't yet present, jaldi se aaja. Right? Sanskar, Shivan, Jia, Mithilesh, Kunal, Shraddha, Evelyn. ठीक है? Okay. Fine. Now dekh le bachalo. Everybody listen here. Now, nowadays we are learning through YouTube, right? Many of us are learning through YouTube, and it's an amazing thing. Okay, I totally appreciate that. There are so many educators, so many amazing contents are also available, but some things you guys are missing. Shall I just remind you what all? Right? I think many of you would love to have a personal guidance, or let's say personal mentoring directly from the educators. Matlab, having an educator to stand right behind you and look at you what you're doing and point out all the mistakes what you're doing. Isn't that something what you're expecting? If that is what you want, the best place for you all to be is the Unacademy Plus subscription platform. Now, in the platform, bachalo, right, there is a chat box. Okay, there we have a question box where you can upload all your doubts, and during the live class itself, educator will be looking into it and will be clearing all your doubts. First thing. Still, let's say your doubt is not cleared, right? Do you have to get worried? No, you guys are in the Plus platform. You can call your educator in the class, talk to him, and through his voice, you can clear all your doubts. Wow. Before you leave the live session, your doubts will be cleared and nothing will be there as a doubt in your mind. That is one amazing thing. Okay. Second thing is that top educators of the country who's having a very good experience about studies will be there to teach you. Because of their high experience, they'll be knowing what all question pattern you should be expecting for examination, what all questions you must be practicing, okay, that so that you can make the best preparation for term 2. So you just follow them. Obviously, you lays in all the examination first of all, and second thing is that you are going to get into the colleges whichever you're dreaming about. What else you need after 12th standard, right? Getting into the colleges that you are dreaming. Then study materials are given, practice tests, live test series, whatever is needed to make your studies in a better way and to give you so much of confidence. Here we have with the Plus subscription. Now, if you go for 12 months, but chalo, it'll cost you 2,250. Now, should you need to pay that much? No. We have our code AMB10. Use this, get 10% of discount and be a part of an Unacademy family with so much of other offers also, and enjoy kar le. Start learning with us. Iconic subscription also we have. Here we have all the features of Plus subscription and some extra features very important and very useful for you. First thing is personal mentor. Matlab, a person will be assigned to you. He'll be there taking care of all the planning of your academic activities. Whatever has to be planned, matlab, how to study, which all topics has to be covered during this week. For everything, this person will be there and he'll make sure that all your topics are being covered before the examination and you will be prepared in the best way for your examination. Now, live doubt solving classes, weekly reports, everything is going to make you super great and better in your studies. Now, if you go for 12 months, bachalo, kitna dena hai? 2,333. Now, do you need to pay that much? Bilkul nahi. Because we have our code, hai na? Code kya hai, sir? Bata de code. Code to ye AMB10. Use it, 10% of discount and maximum offers while you make the subscription. Now, Republic Day, so special to kuch to dena hai. Right? Okay, we are bound to give you some gifts. So this is the gift. If you make the subscription for 12 months or more, extra 6 months is given free. So if you take a subscription for 1 year, it will become 1.5 years of subscription free of cost. And 10% of discount, you know the code, hai na? It's AMB. Don't forget. Now, one more thing. We are dealing with the chapter of dual nature. Those who wish, I think every one of you want, right? If you want to do more number of problems, tomorrow we are having a special class on the same at 4:30. The special classes happens on the platform. It is completely free. Okay, you don't have to be an iconic or plus subscriber. Kuch bhi nahi, it's completely free. If you want to be a part of this, just apply the code of AMD10 in the app and be a part of this class. Don't miss it. We'll be discussing many important questions from this chapter which we are dealing with right now. Okay, that's it. It's time for our studies, as you all know. Let's get started. Okay. Tell me, are you all ready? Ready hai kya? Amritesh, Sanskar, Shreya. Amritesh, Pardeep, Sanskar, everyone, are you all ready? Evelyn, ready? अरे ठंड नहीं, इधर बहुत गर्मी है. I'm in Kerala. It's almost 32 degrees Celsius here in Kerala. So I'm not a North Indian. Evelyn, always ready. Vipu, yes. Srishti, Jia, Anaira, Jay, HRX, Amritesh, Sana. Very good. Shall we get started? Now, I'll just we'll have a quick recap of what we were learning in the last class, right? Because many of you were absent, and whatever we have learned in the last class, we are going to continue about that topic itself in today's class. So a quick recap is very much necessary. So tell me, bacha log, what we were learning about in the last class. We were learning about photoelectric effect. What was this concept of photoelectric effect? The ability of a light to knock out the surface electrons from a metal is simply called as photoelectric effect. है ना? देख ले. I'll just draw a simple figure for you so that you can understand in the best way possible. ये कौन है? हमारा metal था. ठीक है? Metal has so many free surface electrons ऐसे. Yes or no? The light will be coming and this light will be knocking out the electrons, these free electrons from the surface. This process we call it as photoelectric effect, right? And studies were conducted on this photoelectric effect by Harvard and Lenov, right? And we have seen what all observations were being made during that particular experiment. Do you all remember? Right? That is very much necessary. So shall we go once again through that observation that we have made during our study about photoelectric effect? Those observations, okay, we'll talk about it. Very important. We'll go one by one. Everyone, read. Go for the third option first. Matlab, the third one. Starting from the third one, just read. What does it say? For a given photosensitive material, matlab from a metal, frequency of incident radiation, if it has above threshold frequency, the photoelectric current is directly proportional to the intensity of the light. We have learned this, right? We have learned that the intensity of the incoming light is directly proportional to the number of photoelectrons. More the intensity, more number of photoelectrons are emitted, we have seen in the last class. And we also have seen that this intensity has nothing to do with kinetic energy. Intensity has nothing to do with kinetic energy. Iska matlab, though the intensity is increased, kinetic energy of the electrons emitted will not change. Nothing to do with kinetic energy. This was one of the observations we have made. Very important about intensity, right? Okay. Then what we have learned related to frequency. What we have learned about frequency is given here. Shall I explain in my own words? Shall I explain? I think you will love my explanation. Now, for the photoelectrons to get emitted, there should be a minimum frequency. Okay, a minimum frequency should be there. And what did we call that minimum frequency as mara bachcha log? That is called as threshold frequency. Naam kya tha uska? Threshold frequency. Very important. For the photoelectric effect to happen, a minimum amount of frequency has to be given, right? And that minimum frequency was threshold frequency. Matlab, there exists a minimum frequency called threshold frequency. Now, let's say we are providing a frequency greater than threshold frequency. Matlab nu, the frequency is greater than nu naught. Nu naught is threshold frequency. What will happen? The electrons are emitted with a kinetic energy. We will write it here. Electrons emitted with kinetic energy. Okay, one more thing we have seen, that the frequency is found to be directly proportional to kinetic energy. Matlab, after threshold frequency, if we keep on increasing the frequency of the light, it was found out that the kinetic energy of the emitted electrons was also increasing. This is the second thing that we have observed in the yesterday's experiment conducted by Leonard and Hallberg. Right? One more thing. Last thing we have discussed, ek aur, matlab there was no time lag. Matlab the moment light falls on the metal, the photoelectrons are being emitted. Right? There is no time lag. Okay? It is not like light will be coming. Okay? Electrons will wait for some time. Theek hai, let the light come. Okay? And I'll be in my own position. I'll take some time and leave after some time. Aise nahi hai. Okay? The moment light falls on the metal surface, electrons are being emitted. Matlab, there is no time lag. Isn't this what we have learned in yesterday's class? Bata de bachcha log, bata de everyone. है ना? ये this is all the topic that we have covered in yesterday's class. Just confirm me, sir. हाँ, इधर तक आप तो पढ़ा है, हम पढ़ा भी है. How many of you came after revising this topic? कौन आया है in the class after revising all these topics? I want to know. I really want to know because ये तो बहुत important है. Okay, so who all? Gia did. Shreya, Vipu, Evelyn. Shreya, then Shrishti, Priyanshu, Mithilesh, Nisha, Jia. Okay, so I think many of you have did the revision, learned all these topics and came. ठीक है? Fine. Nisha, very good. Neha. Okay, everyone did the revision and came to the class. ठीक है? We are going to continue. Now, all these observations were found out whenever the experiment was done on photoelectric effect, right? Now, at that time, the only existing theory about light was wave theory. Matlab, at that time, it was believed that the light is moving from one point to another point in the form of waves. That is what is called as wave theory of light. Obviously, if that is a theory accepted for light by the scientists during that time, by using that theory, we should be able to explain all these properties. All these observations of photoelectric effect should be able to be explained by wave theory. Q. Because we believe that, or scientists believed at that point of time, that light is a wave. So by using the wave theory, we should be able to explain all the observations that we have made in photoelectric effect, right? So scientists started to make the explanation. So shall we also find out how these are being explained, how these observations are being explained using wave theory of light? ठीक है? Let's see. Everybody listen here. It's very important. Let's say super important. According to wave theory of light, we are going to explain photoelectric effect. If you want, we can write the heading. According to wave, क्या है बच्चा लोग? Wave theory. ठीक है. According to wave theory, let's see how we can explain this photoelectric effect. ठीक है. So this is our metal. So many electrons are waiting on the surface. ठीक है. Light waves आ रहे हैं. Light waves are coming. ऐसे. Light waves are coming. Light waves are coming. Okay. Let's say the light coming is having an intensity of I. ठीक है. Now we have learned the chapter of wave optics. We have learned that the intensity of light is directly proportional to square of amplitude of electric field and magnetic field. Sir, electric field and magnetic field कहाँ से आ गया? Light is an electromagnetic wave, right? It has electric field and magnetic field. So if we talk about amplitude, it is the amplitude of electric field and magnetic field. If you want, I can write electric field and magnetic field का amplitude. So if the intensity of the light is increased, amplitude of electric field and magnetic field increases. Q. Intensity proportional to square of amplitude. Now, if the amplitude of electric field and magnetic field increases, large value of electric field and magnetic field will be coming. If large value of electric field and magnetic field comes, what will happen? Energy and incoming energy will also increase, which means if the intensity of the light increases, the energy of the incoming light increases, right? So if energy of the incoming light is increasing with intensity, can't a light with sufficient energy can knock out an electron from it? According to wave theory, a light of sufficient intensity should be able to knock out the electrons irrespective of threshold frequency. Whatever may be the frequency, it doesn't matter. According to wave theory, if a light is having sufficient intensity of light, it should be able to knock out the electrons. But this is not happening. This is actually a contradiction to what was observed in the photoelectric effect. है ना? What was observed in the photoelectric effect? I have wrote it here. We have wrote that intensity has nothing to do with the kinetic energy or energy. That was observed in the photoelectric effect. By increasing the intensity, we cannot make the electrons to pop out until there is a minimum frequency of threshold frequency. This was observed. ठीक है? अब once we try to explain the same thing using a wave theory of light, we are getting just the opposite. मतलब contradiction आ रहा है. So is wave theory the only theory existing, or can wave theory explain this photoelectric effect? Can wave theory explain this photoelectric effect? The simple answer. What is the simple answer? The simple answer is no. Once again, wave theory cannot explain photoelectric effect. Why? According to wave theory, once again, okay, I'll write it. According to wave theory, I'll write it so that everybody can write. According to wave theory, but chalo, I'm writing here on the board so that everybody of you can copy this down. Okay? According to wave theory, a light of sufficient intensity, light of sufficient intensity should produce photoelectric effect irrespective of frequency. ठीक है? And this is exactly the opposite what was observed in the photoelectric effect. That is the reason why it is told that wave theory cannot explain photoelectric effect. ठीक है? Because according to what is observed, frequency matters. There should be a minimum frequency for photoelectric effect to happen. ठीक है? And it also says if the intensity of the light is more, right, the photoelectrons cannot happen, right? Irrespective of whatever intensity is, there should be a minimum frequency for photoelectric effect to happen. But here it says that if light is having enough intensity, electrons should be coming up. So ये तो गलत है. So this is a contradiction. This is a contradiction. तो आ गया समझ. First thing very important है. ठीक है? Because in the question paper they'll be asking you, right, why wave theory cannot explain the photoelectric effect. You all know we are going to write subjective examination, है ना? सबको पता है. श्रेया, एवलीन, सुमित, कुणाल, तन्मय, जिया, सब बोल दे. Are we going to write subjective examination? है ना या नहीं? हाँ या नहीं? बोल दे. Yes. So can't there come a question like this? Yes, it can come. So shouldn't you be able to write this? Isn't it? Yes. Khushbu, Neha, yes. Evelyn, yes. है ना? मिथिलेश yes. So आ गया समझ? I have written in the best way possible. Just read the statement, that is more than enough. ठीक है? कुणाल, श्वेता, सुमित, स्वाति. Very good, very good, very good. देख ले, it's amazing. Now, this is not only the one point, okay, which is acting as a contradiction. There is one more point where the wave theory is acting as a contradiction. Shall we also look into it? What is that extra contradiction added by wave theory to the observations of photoelectric effect? Let's see. Everybody, देख ले. Same, हमारा मेटल, ठीक है? मेटल पे क्या है मेरा बच्चा लोग? बहुत सारा फोटो इलेक्ट्रॉन्स है, ठीक है? बहुत सारा फोटो इलेक्ट्रॉन्स है. Now, to this metal, waves of light is coming according to wave theory. Light waves are coming. Fine. Okay. Now, let me say that for these electrons to get emitted, a minimum energy is required, isn't it? Let's say that minimum energy is equal to E. Okay. Or let's make it as phi naught. That was a simple, right? What do we call this? याद है? We call it as work function. Minimum energy required for the electrons to get emitted. Minimum तो चाहिए ना, because it has its own standard, right? Okay, वो minimum energy को we call it as work function. ठीक है? Fine. Now let's say light is coming, okay, and this light is having an energy of phi naught. What is the light energy? Okay, what is the energy carried by this waves of light? Phi naught. देख ले, this has phi naught. This phi naught energy of light is being distributed. Is it given to one single electron? No. It is being distributed between this n number of electrons. Phi naught is energy is coming. It is being distributed to n number of electrons. So each electron will be getting how much? Phi naught by n, because phi naught, what is incoming, is being distributed between n number of electrons. So will this electron be getting emitted? No, because it needs phi naught amount of energy. So what will these electrons do? Electrons will wait. Okay, electrons will wait until the waves keep on bringing energy. Okay, the energy keep on getting added up in this electron until this becomes phi naught. Okay, energy get absorbed by the electron. It keeps on absorbing until it becomes. इसका मतलब, right, that whenever the light wave hits, the electrons are not getting emitted. Okay, electrons will take some time here for absorbing all the energy to get emitted from the surface. Matlab, according to wave theory, there will be what? There will be time. According to wave theory. According to wave theory, I'll write. According to wave theory, there will be a time lag because electrons are waiting for the entire energy to get received. So time lag ho jayega. Isn't this also a contradictory? Yes or no? Because what was observed? It was observed that the moment light falls on it, hai na? Okay, electrons will be actively waiting for the light waves to come. ठीक है? The moment light falls on the electrons, what was observed? The electrons will be emitting out. That was observed when the experiment was done. But here it says thoda time lag is there. So isn't this a contradiction? Isn't this also a contradiction? Why? Because it was observed that there was no time lag. There was no time lag for photoelectrons to get emitted. This is the second contradictory statement coming with wave theory of light. बहुत important है बच्चा लोग. बहुत मतलब इतना. I usually say नन्नू मुन्नू है ना, ये तो बिल्कुल opposite of our नन्नू मुन्नू. बहुत important है. आ गया समझ? Those who are clear about these two contradictions, right? Raise your hands. जल्दी से raise your hands. अरे थोड़ा energy दिखा. This is the day of Republic Day, right? So you should be having full of energy. Clear? आ गया तो आ गया, बिल्कुल समझ में आ गया. Awesome, Evelyn. मिथिलेश, clear. संस्कार, सुमित, खुशबू, एनेरा, श्रेया, सृष्टि, ठीक है. Okay, everybody is clear. Everyone is clear. Everyone is clear. Sapna is clear. Jia is clear. Khushbu is clear. Sana is clear. Arey, I'm so happy, है ना, to see this much of hands raised here in this class. So the entire scientific world was stuck. Kyun? Because the only theory existing related to light was wave theory of light. So when they try to explain photoelectric effect, which is a phenomenon of light, by using the existing theory of light, which is a wave theory, they were not able to explain. So they started to confuse, they got confused, they started to doubt that whether the light is actually a wave itself. Okay, so obviously then there came a man who has answers for everything. Okay, the man with the greatest and amazing mind, Khan, who will be coming to solve the doubt of everyone, right? Okay, who will be coming from thin air and will be solving all the doubts. And now whatever problems happens in physics, this person will be there. Do you know whom I'm talking about? None other than our Albert Einstein. So Albert Einstein came, and he came with Einstein's photoelectric theory. Do you want to know how he explained all these observations of photoelectric effect? जानना चाहिए बच्चे लोग, आपको जानना चाहिए, right? देख ले how he have tackled this awesome problem with an amazing solution, right? It is so much amazing. He said that, okay, first I'll explain, देख ले. He said that from a source of light, okay, the energy is coming as packets of energy. एक packet of energy, another packet of energy, another packet of energy. ऐसे packets पे आ रहा है energy. Okay, energy is coming as packets from the light source, and he gave a name for this packets of energy also. नाम क्या था? What was the name given? And this was called as photon. So this capsules of energy which is being emitted from the source of light, we called, or he called, Anna, after he gave a name, we started calling it, we call it as a photon. Then everyone started to ask, right, Einstein, right, if we give this particle nature, right, to the light, we won't be able to explain diffraction, which we have learned in wave optics, right, according to the wave theory of light, interference, which happens according to the wave theory of light. He had a solution for that also. He said light will not be exhibiting this particle nature, where particles are called as photons, right? It won't be exhibiting this particle nature all the time. Then whenever the light is interacting with another material, matlab when light is interacting with a ball, when light is interacting with a table, right, when light is interacting with a chair, when light is interacting with a camera, right, whenever the light is interacting with a matter, something which has a mass, right, at that time light will be acting as a particle nature, where the particles are called as photons. Dekh, whatever is given in the first statement, is it exactly what I have told you right now? Obviously yes. Obviously yes. Dekh le. In interaction of radiation with matter, when light waves are interacting with matter, radiation behaves as it is made up of particles. Okay, and what do we call those particles as? Particles are called as photons. Okay, naam hai photon. And he said each photon is having an energy. Okay, it also has a momentum. How much energy is associated with each photon? If this light is having a frequency of nu, the energy of each photon is given as h nu. Each photon will be having an energy of h nu. Does it have only energy? No. Einstein told that along with energy, it has momentum. It is a property of a particle, right? If anything has a momentum, it means it has a particle nature. Okay? It is also associated with the momentum, and the momentum associated is given by h by lambda. Okay. We know one more formula, right? If you want to make the conversion, use kar le. We know frequency is equal to velocity by lambda, or 1 by lambda is equal to this c when it comes to the left hand side, frequency divided by velocity of light c. So 1 by lambda, h by lambda can be written as 1 by lambda is nu by c. So energy is equal to h nu, okay, and the momentum is h by lambda, or making the conversion to 1 by lambda as nu by c. Very, very, very important. And it is on the basis of this we'll be proceeding further. Very important. Copy kar le. Everybody copy this, okay, and try to write down everything possible so that you will not forget this. Okay, भूल मत जाना ये, ठीक है, भूल मत जाना, भूल मत जाना. अरे please, if someone is spamming here in this class, मत कर ले Sachin Arodhia, because students है ना, बच्चा लोग are using for sharing the information, asking the doubt, ठीक है, मत कर ले, please don't do it. Yes, Sachin, Sushant, HRX, आ गया ना समझ? Clear and written, खुशबू, विप्पू, ठीक है, ठीक है, बढ़िया, हम चल रहा है, because we have lot much to discuss. So first two parts are being cleared. ये भी हो गया, ये भी हो गया. Let's go to the third point. Read everyone. All photons of light of a particle frequency nu and wavelength lambda has the same energy. Obviously, if frequency is same for the photon, energy is equal to h nu. And now, until frequency changes, energy will not change, because energy is equal to h into nu. ठीक है, अरे मैं भूल गया to tell what was h. ये h है ना, I think you already might be knowing, those who don't know, that was called as Planck's constant. Okay, it is a universal constant. Okay, so Planck's constant is h with a value of 6.6 into 10 power minus 34. Planck's constant 6.6 into 10 power minus 34. This is very important. मैं तो भूल गया, ठीक है, to tell you all. This h is equal to, it's a constant value with a value of 6.6 into 10 power minus 34. ठीक है. Now, as it is being said in the first part of the statement, for a photon of frequency or 2-3 photons or more than one number of photons, if both of them have same frequency or wavelength, the energy will be same for them. ठीक है. Okay. Then, what does it say? The increase in number of photons crossing in a given area. देख ले, increasing the intensity. Start reading from here. By increasing the intensity of light of given wavelength, there is only increase in the number of photons per second crossing a given area, with each photon having the same energy. Thus, photon energy is independent of intensity of radiation. देख ले, everybody listen. What is being explained? We'll take a new page. इधर तो बहुत लिखा है, ठीक है. Tell me, what is the formula for intensity of light? Light का intensity का formula क्या है? It is the energy that is being received per unit area per unit time. Okay, मतलब if I take a surface, okay, क्या कर रहा है बच्चा लोग? हम क्या कर रहे हैं? I am taking a surface of area 1 meter square. Okay, the energy received to this area, okay, energy received to this 1 meter square area in 1 second is simply defined as intensity. ठीक है, 1 meter square area पे in 1 second कितना energy is there, that is called as intensity. Now we know that if light is coming, lights are coming as photons. If one photon comes, the energy is h nu. So to this area of 1 meter square, is it only one single photon that is going to come? No. We can see that n number of photons is coming. ठीक है, n number of photons आ जाएगा. So if the intensity is increasing, means energy received in an area of 1 meter square in 1 second is increasing. How that is being increased? So intensity will only be increasing if the number of photons received by this area increases, because each photon has an energy of h nu. If 2 photons come, 2 times h nu. If 3 photons come, 3 times h nu. If n number of photons are coming, the energy received will be equal to n times h nu. So more the number of photons comes to this area, okay, more will be the intensity of light. Okay, which means the intensity of light is directly proportional to the number of photons passing or receiving through an area of 1 meter square in 1 second. That is important. What is intensity of light? Once again, according to photon theory, the number of photons. Very important. Okay, intensity matlab, what is intensity? Number of, we'll write, बहुत important, number of photons received per unit area per unit time. ये होता है what? Intensity. ये भी लिख ले चलो. Only this much is very important related to this photon theory. बाकी सब simple है चलो. Remaining things are very, very simple. If you are clear till this part, it's fine. Particle nature, photon. Photon's energy is h nu. Intensity matlab number of photons received per unit area per unit time. Only this much we have discussed, और कुछ नहीं. हो गई बात इधर तक? Have you all wrote this? Yes? कोई भी doubts नहीं है ना? ठीक है, ठीक है, ठीक है, ठीक है. Now we'll discuss the very last 2 more points from here, and we'll finish off this Einstein's theory. Okay, photons, Einstein photoelectric theory. We'll finish it off. देख ले. Photons are electrically neutral. मतलब photon doesn't have any charges. It is neither positive, it is neither negative. It is completely neutral. As it is neutral, they are not deflected by electric and magnetic field. Okay, there is nothing more for me to explain there. ठीक. और क्या है? और क्या है बच्चा लोग? और क्या है? देख ले. In a photon particle collision, मतलब let's say a photon and an electron is colliding. Is it going to be an elastic collision? Yes, it is going to be an elastic collision, which means energy will be conserved and momentum will also be conserved. This is very important. Okay, for your higher studies, this is very important. We are not going to use the collision of photons and a particle here in this particular part, but understanding this is important because in the question, है ना, question paper में पूछेगा, what are the postulates of Einstein's photoelectric theory? We have to write all these things. ठीक है, very important. Now, however, the number of photons may not be conserved. मतलब ये है कि let's say that we have a particle here. 3 photons are coming. It is not necessary that this photons comes, it will be getting incident on this particle. It will be reflecting 3 number of photons. Why? Because sometimes photons is basically packets of energy. है ना? Sometimes these photons will get absorbed to the material. Okay, let's say 1 photon is getting absorbed, remaining 2 will be bouncing back after reflection. So is the number of photons conserved here? Number, it is not necessary that number of photons has to be conserved. Einstein told that, right? Energy and momentum will be conserved here. Okay, this is the important part. ये तो बहुत important है. Okay, this was all about हमारा Einstein. Everybody go through this. Just go through this, है ना? Everybody, I'll just remove this. Go through all these important parts here and tell me if you have any doubts. And those who haven't noted it down, jaldi se note down kar le. Sir, may I go out sir 1 minute? Hey, you were asking this question for the past 1 minute. Jaldi se aaja, theek hai? Whichever parts you are missing, hai na? Please do watch the replay. Clear? Note down. Sumit, Khushbu, Anisha. No doubts. Okay, hola, sub clear, right? Happy Republic Day, Shreya. Good to have you here. बहुत बढ़िया, बहुत बढ़िया. Clear, clear and noted. अरे वाह मेरे बच्चा लोग, बहुत बढ़िया है. बहुत बढ़िया है, पूरा नोट किया। हैप्पी रिपब्लिक डे। ठीक है ठीक है ठीक है, बढ़िया। सो शैल वी कंटिन्यू? थोड़ा और कॉन्सेप्ट्स का बाकी है। Okay, then we are going to start doing so many problems. You guys are all excited for the problems, right? Because theory, after you learn, it is so much necessary that we have to apply it in some problems. Then only our study will be complete, and that is what we are going to do. Study कब complete हो जाएगा? चलो कब हो जाएगा? हाँ, जब हम theory study करेगा, theory पढ़ेगा, फिर theory के बाद question करेगा. So theory तो almost will be over within 10 more minutes. Now उसके बाद question का time है. क्वेश्चन के लिए रेडी हो जाओ, चलो बाकी क्या है अभी. नाउ Einstein have introduced a new theory with respect to light. So right now light has wave theory. कब? When light is interacting with other lights or other radiation, it is having the wave theory. ठीक है. Light is having the particle theory according to Einstein, right? When the light is interacting with another particles. So with this particle nature, we should be able to explain all the observations of photoelectric effect. Right? This was the exact reason for having a new theory of light. Okay? So right now we are going to explain what the photoelectric effect using the particle nature of light, which is photon. Everyone ready, Anna? Write the heading. Explaining what are we going to explain? क्या explain करने जा रहे हैं? Explaining photoelectric effect. Photoelectric effect with photon theory. Okay, so we'll start. Okay, shall we begin? ठीक है. Tell me, what was the first observation that was made in photoelectric effect? What was the first observation? The first observation was intensity is directly proportional to number of electrons emitted. Isn't it? Yes. Let's see whether the photon theory or the particle nature of light can explain this part. Everybody listen बच्चा लोग. ये कौन है? ये है हमारा metal भैया, right? From on which we were continuously doing experiment. I know that metal भैया is tired, but we have to do the experiments, है ना? ठीक है. It is having so many metal, है ना? बहुत सारा free electrons हो जाएगा. ठीक है. On this, what is coming? Light is coming. And how lights will be coming? Light will be coming as photons, as particle, with each photon having an energy of h nu. What will happen? A photon will come. It will be striking out an electron if the incoming photon has enough energy. ठीक है? If the incoming photon has enough energy, one photon come, it will be striking out one electron. Another photon come, it will be striking out another electron. मतलब the moment photons comes, right, it will be emitting the electron. मतलब here according to particle nature, according to particle theory of light, there is no time lag. है ना? So this photon theory was successfully able to explain this observation of having no time lag. Why? Because the moment light falls on it, a photon comes, it will be striking out an electron. Photoelectric effect happens. Another photon comes, it will be striking out another electron from here. समझ में आ गया? मतलब the moment photons falls on it, electrons are being emitted. There is no time lag. So whatever was observed, that is explained. First thing. Second thing, how can we explain this part? देख ले. Intensity is more मतलब more number of photons. More number of photons matlab more number of collision with the electron, more electrons are being emitted. So is photon theory is able to explain the photoelectric effect? Yes, because more photons, more collision, more electrons are emitted out. Obviously intensity, thus we prove that intensity is proportional to number of electrons emitted. Okay, simple है ना? इंटेंसिटी मोर मीन्स, मतलब क्या है, इंटेंसिटी मोर का मतलब क्या है, मोर इंटेंसिटी मोर नंबर ऑफ फोटॉन्स, more photons, where each photons will be striking out one single electron. So more number of photon matlab more number of electron, that is more number of electrons. देख ले, two observations are being explained by using this photon theory. देख ले कितना आसान है. कितने आसान है. Okay, so we have explained the first part. आ गया समझ सबको, आ गया समझ सबको, जल्दी बोल दे. हाँ सर बिल्कुल समझ में आ गया, अच्छे से समझ में आ गया. यस ऋषभ, सृष्टि, सपना, विपू, क्लियर. हाँ ओके. नाउ अभी क्या बाकी है, एवरीबडी राइट डाउन कर ले. I'll give you some time. Write it down. Whatever is being required in your own words, आराम से write it down. Very important it is. Clear एवलीन, सपना, कोई भी डाउट है तो पूछ ले. Yes, yes, yes. Okay. So I think everybody of you have noted this down also. बढ़िया, बढ़िया. Now we have to go for the explanation of the second part. मतलब the existence of a threshold frequency, right? And increasing the frequency above threshold should be increasing the kinetic energy of the emitted. Two things we have to explain. What? What all we have to explain? We have to explain the existence of what? Yes, threshold frequency. The existence of threshold frequency. इसका explanation बहुत important है, right? Okay. Now we know that according to observations of photoelectric effect, there was a minimum frequency called as threshold frequency. Let's see how photon theory can explain this threshold frequency का concept. देख ले, everybody listen, everybody listen. हमारा मेटल भैया, ठीक है, from a very long time we were doing experiments, है ना? And this metal has so many free electrons. ठीक है. Now for the electrons to get emitted, we have to give a minimum energy. We have learned, right? ठीक है. What was the minimum energy called as? It was called as work function. ठीक है. Minimum energy was called as work function. Minimum energy. ठीक है. And the symbol was phi naught. मतलब for an electron to get emitted, a minimum energy of phi naught has to be given. A minimum energy of phi naught has to be given. इसका मतलब the photon of incoming light, okay, which is giving the energy to the electron, should be carrying an energy of phi. If it is carrying a minimum energy of phi naught, obviously this electron will be emitted out. Tell me, what is the formula for energy of a photon? Energy is equal to h times nu. So the minimum energy of the photon should be equal to h times nu, that should be equal to phi naught. Okay, so you can see that the minimum energy of the photon is associated with the minimum amount of frequency here, right? Can you see that? Because energy is equal to h nu. For having a minimum energy, there should be a minimum amount of frequency here, and this minimum frequency is called as what? This minimum frequency is called as, मेरा बच्चा लोग, threshold frequency. Okay, so h minimum frequency is equal to h nu naught. Why nu naught? Because nu naught is the symbol we use for threshold frequency. और कुछ नहीं. Okay, nu naught is the symbol we use for threshold frequency. H nu naught is equal to phi naught, which is the work function, and nu naught is equal to phi naught divided by h. ये भी important है, ये भी important है. देख ले, successfully we have explained the existence of threshold frequency. मतलब minimum energy, if there has to be a minimum energy, there has to be a minimum frequency. नाम है उसका Nama's dawn, na na na. Threshold frequency. ठीक है? ठीक है ना? Write it down. What all you have to write? Electrons to get emitted, work function of phi naught has to be given. मतलब minimum energy phi naught. Then what do you have to write? Minimum energy is given by photon. So the minimum energy of photon should be equal to phi naught, which is equal to h nu, because energy of photon is expressed as h nu. So the frequency of the light to have minimum energy, we are writing it as minimum frequency. Okay, and that minimum is threshold frequency. H nu naught is phi naught, nu naught is phi naught by h. Very important. Okay, एक छोटा और derivation है, उसके बाद we are done with this photon theory. बहुत सारा questions are waiting for us. 4 more minutes, which means by 9 o'clock we will start solving problems. Okay, done. अरे syllabus के बारे में कुछ नहीं सोच लिया अब, ठीक है? Everything will be completed before the examination time. ठीक है? You just give us so much of love, ठीक है? बहुत सारा likes भी दे दे. Those who haven't liked, you all can like the classes, ठीक है? बहुत सारा likes भी दे दे. So everything will be done before your examination, है ना? Almost by the end of February you'll be completing the syllabus. Don't worry at all. ठीक है? Done मेरा बच्चा लोग. Okay, moving. Last part of this photon theory is Einstein's. All the numerical questions are based on this. Einstein's photoelectric equation. Einstein's photoelectric equation बहुत important. Everybody, हो गया क्या? हो गया बच्चा लोग हो गया क्या? हो गया? Writing down the heading, हो गया ना? ठीक है, देख ले. Everybody listen here. Everybody listen here. फिर भी हमारा मेटल भैया आ गया with so much of free electron. Okay, so much of free electrons के साथ हमारा मेटल भैया आ गया. ठीक है? To this metal, what is incoming? What is incoming? Photons. So many photons are coming. I'm only considering one single photon. Let's say it is having an energy E of h nu. What is the energy? H nu. Let's say that this h nu is greater than phi naught. Phi naught क्या था? Work function. Minimum energy required for the electrons to get removed. ठीक है? बहुत सारा energy आ रहा है along with photon. Anything can happen मेरा बच्चा लोग. ठीक है? Collision हो गया. ठीक है? This energy of h nu is given by the photon to electron. Collision हो गया. ठीक है? उसके बाद क्या हो रहा है? ठीक है? Some of the energy from h nu is used for electrons to get emitted. कितना energy is that? Phi naught. मतलब from the incoming energy of E, some energy is given for phi naught. But the incoming energy is greater than work function. What will happen to the remaining energy? What will happen to the remaining? अरे, the emitted electrons has to move, है ना? If it has to move, speed होना चाहिए. With speed, which energy is associated? Kinetic. मतलब from the total energy that is being transferred from photon to electron, ठीक है? Some energy is used for giving work function, remaining is used for kinetic energy. Very simple. And ये है Einstein's photoelectric equation. In very simple way, in a numerical way, I'll explain. देख ले, हमारा ये work function है ना, phi naught. Let's say it is 7. The incoming energy is equal to 10. So photon will be giving 10 energy. ठीक है? 10 units of energy is being given to this electron. But this electron only require 7 to get emitted. So from 10, 7 is being used. 10 तो दे रहा है, 7 is being used. What will happen to this remaining 3? Remaining 3 will be used for giving kinetic energy for the emitted electron. The electron has to move, है ना? जाना चाहिए ऐसे. ठीक है, ठीक है. You'll be asking, sir, ऐसे जा रहा है क्या बाहर? नहीं, थोड़ा और है कंप्लीट करने के लिए. ठीक है? So some of the energy is used for giving the kinetic energy and remaining is used for work function. ये है हमारा Einstein photoelectric equation. बस आ गया ना समझ, आ गया ना समझ. Now what we have to do is make some simple substitution. बस E energy of photon h nu, ठीक है. So h nu is equal to ke plus phi naught. Make it as an box. Again you can rearrange kinetic energy ke is equal to h nu, phi naught will come to the left. So h nu minus phi naught. Another equation. How many of you do remember the equation for kinetic energy? याद है kinetic energy in terms of stopping potential. Try to remember. Sir, kinetic energy stopping potential formula है. Is there any formula? Maximum kinetic energy. अरे भूल गया. EV naught. How many of you do remember? Electronic charge E into stopping potential was the kinetic energy of emitted electron. Remember yesterday we have derived. Very important it is. ठीक है. Those who are absent in yesterday's class, do watch yesterday's class after this. ठीक है. So yesterday मतलब Mondays का class. ठीक है. E V naught is equal to h nu minus phi naught. Very 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 important. अरे बाप रे, अरे बाप रे, अरे बाप रे, थक गया मैं. चलो बहुत इंपॉर्टेंट है. क्या है? बहुत 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 इंपॉर्टेंट है. राइट इट डाउन. Whatever doubts you have, your time, you can ask me. मॉन्स्टर टेक्निक. बिल्कुल रिप्लाई तो बिल्कुल करेगा मैं. और क्या काम है मुझे? बोल दे, पूछ ले. आपको क्या रिप्लाई चाहिए? सर आज एक सॉन्ग रिपब्लिक डे के दिन के डेडिकेटेड टू आवर कंट्री. बिल्कुल ठीक है. एट द एंड ऑफ द सेशन वील बी हैविंग अ वेरी ऑसम ब्यूटीफुल सॉन्ग. ठीक है. फिर सर मोर देन अस यू आर गेटिंग सीरियस अबाउट दिस कॉन्सेप्ट. अरे सीरियस होना ही चाहिए है ना. वंस आई हैव दैट सीरियस वाइब इन माय फेस है ना, यू विल आल्सो स्टार्ट हैविंग दैट थिंग. ठीक है. जस्ट लाइक इंडक्शन ऑफ करंट फ्रॉम इलेक्ट्रोस्टैटिक्स. ठीक है. ट्रांसफरिंग द चार्जेस है ना, ऐसे याद है. ऐसे ही होता है. सो वंस आई हैव दैट इंपॉर्टेंट फेज यू विल आल्सो थिंक हाँ सर इज टेलिंग समथिंग सो सीरियस. ठीक है. आई हैव टू लिसन. ठीक है. वो ही कर रहा है. ओके ओके हो गया ना सब. ठीक है ठीक है. अरे मैं तो बिल्कुल बढ़िया उदित, बिल्कुल बढ़िया. ओके वापस आ जाए एवरीवन. एक छोटू रीअरेंजमेंट है. ठीक है. छोटू रीअरेंजमेंट है. सो ई वी नॉट will give you the unit of energy in which joules. H nu will give you the energy in joules. ठीक है. phi naught will give you the energy in joules. Fine. ठीक है. Now हम थोड़ा एक छोटू मुन्नू नन्नू मुन्नू चेंज करेगा. The change is that V naught is equal to, taking this E to the denominator on the right hand side, how will it be? H nu divided by electronic charge minus phi naught by electronic charge. अरे सर अब क्या हो गया? We made an equation for stopping potential here. Okay. Now what does this h nu by E means? That is very important. h nu by E क्या होता है सर? देख ले. I'll tell you. h nu was energy है ना, energy of incoming photon with the unit of joule. Once you divide it by electronic charge, to which unit it will be converted to? I'll tell you. देख ले. Very simple. 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Electron volt is a unit of energy. Joule is another unit of energy. Electron volt is okay छोटा unit of energy. देख ले 1 electron volt is 1.6 into 10 power minus 19. बहुत छोटू है. From here 1.6 into 10 power minus 19 is the value of electronic charge E. So you can write 1 electron volt. अरे don't cancel this E and E. ठीक है. Electron E, this EV is a short form for electron volt, another unit of energy. ठीक है. So मत cancel कर ले. So this is E joule. Rearranging, 1 joule is equal to 1 electron volt divided by E. 1 joule is equal to 1 by E electron volt. So H nu joule will be equal to, H nu in joule will be equal to 1 joule is 1 by E. So h nu joule will be, 1 joule is 1 by E, 2 joule will be 2 by E, 3 joule will be 3 by E, h nu joule will be h nu by E electron volt. है ना? मतलब this h nu by E is the energy of photon in which unit? In electron volt. Similarly, phi naught by E is work function in electron volt bus. I just needed you to understand this. H nu by E is the energy of the photon, ठीक है, in electron volt. Basically, once you divide the unit of joule with electronic charge, that will be converted to another unit of energy, which is electron volt bus. I just wanted to explain that. ये तो समझ में आ गया? समझ में आ गया है ना? ठीक है, फाइन. देख ले. Before going to that, Chotuza, I want to give you a short trick. Okay, एक trick देना है. We know that energy of photon is h nu by E in the unit of electron volt, right? Nu is frequency, so h frequency is equal to c by lambda, right? Frequency is equal to velocity by wavelength. This E existing, this is an electron volt. H is 6.6 into 10 power minus 34. C, velocity of light, is 3 into 10 power 8. Electronic charge is 1.6 into 10 power minus 19. Now, if you apply the value of all these things, the number you get is 1240 divided by, we have lambda, wavelength, right? So, let's say in the question, wavelength is given in nanometer. Now, do you need to do this entire problem? Matlab h ka value, c ka value, e ka value. Do you need to find all these things? No. All these values are being found out, which is 1240. Divide 120 by wavelength in nanometer. You will get the energy of the photon in electron volt. समझ में आ गया? अरे simple trick है बस. मतलब this value is being did beforehand, so that you can use it during your examination time and all the times very easily. ठीक है? Understood? 1240 by wavelength. This wavelength has to be substituted in nanometer. Let's say wavelength is given in Armstrong. Very simple. 12400 by wavelength in Armstrong. एक और zero add कर ले. Once you are substituting wavelength in terms of Armstrong, we'll get the energy. We'll get the energy in the units of electron volt. ये तो आ गया तो बता दे. Question करने का वक्त आ गया ना समझ? This one also, write it down. Very important. Shall we start doing the questions? बच्चा लोग, full ready for the questions, Evelyn? और कौन? Who all are super ready for the questions to get started? HRX, Sumit, John, Khushbu, Vippu. Okay, पूरा जोश पे. ठीक है. जल्दी नोट कर ले. अरे ये कौन आ गया? जावा. रेडी. ठीक है. Super duper ready. First question it is. A simple question related to what? Related to our equation, right? Or a graph. Arey yaar, who's making the sound? Between the graph between this stopping potential and frequency. Stopping potential and frequency का एक graph दे दिया है, ठीक है? And we are asked to solve this. Done. Okay, you'll be like, sir, you are covering that question, sir. Ab move kar le, sir. Anyone want to give me the answer? The only person to give me the answer here. Okay, now 2 people. Or 3 people दे दिया. Mithilesh दे दिया option A. Okay, Sumit A, Khushbu A. Confused on A and C. I'll explain. Okay, I'll explain. Okay. Sapna hai? Yes, bachcha look. Very good. The correct answer is option A. Shall we explain? The stopping potential V naught for photoelectric emission from a metal surface is plotted along the y-axis. मतलब along the y-axis इधर stopping potential is here. देख ले. Okay. And frequency is being plotted on the x-axis. Fine. Okay. Now Planck's constant is given by. From this graph, how can we obtain हमारा Planck's constant h value? कैसे करेगा? अरे very simple है. Okay, do you know how we can do this? Very simple. You just need to write down the basic formula for stopping potential. How much it was? Stopping potential V naught is equal to H divided by E nu, H nu by E minus phi naught divided by E. This is an equation for stopping potential and frequency. How can you compare? Array, just compare it with the basic equation for a straight line, y equal to mx plus c. On the y-axis, stopping potential. On the x-axis, frequency. There we have, right? If you cannot see, I'll just move. Okay. Fine. So, whatever is the coefficient of x, right? So, whatever is the coefficient of the quantity plotted on the x-axis. What is the quantity plotted on x-axis? Frequency. That will be corresponding to m. M matlab slope. Matlab the slope of the graph plotted between stopping potential and frequency is h by e. You wanted to get h. So how can you get h from here? H is equal to e into m. Matlab, you just need to take the product of m is not mass, okay? Don't get confused. M matlab slope and charge of an electron. देख ले. Product of slope of the line and charge on the electron. Who is making sound? Sound कौन बना रहा है? जा भाई जा. हमको नहीं चाहिए sound, है ना? So we just got that. The product of slope, I was also telling mass, product of slope and electronic charge will give us what? H. H कौन है? अरे H कौन था भाई? H was Planck's constant. आ गया समझ? Have a look at it. Take 10 seconds for analyzing this problem. Clear? आ गया समझ? Yes, HRX, सुमित, सपना, एवलीन, संस्कार, बहुत बढ़िया. अगला क्वेश्चन. ठीक है. Now I don't want any one of you to leave the class for the next 20 minutes. ठीक है. We'll be doing as many questions as possible. So do this. I have told you the exact method how to do this problem. Take 30 seconds of time. देख ले मैं कितना अच्छा वाला भैया है. 30 seconds दे रहा है ये छोटा क्वेश्चन के लिए. कर ले, करके बोल दे आंसर क्या है. Is it done? बच्चा लोग Is it done? हो गया बात? Mithilesh is giving me the option C here. Sumit is going for the option C here. Evelyn is going for the option 2.1. Khushbu is going for the option C. The correct answer is given by Evelyn. Very good. It's 2.1. I'll explain. Okay. I will explain how this particular question can be done. देख ले. I'll explain by including all the concept that we have discussed. बच्चा लोग इधर. Photoelectric work function of potassium is 2.3 electron volt. What is given? Yes, the phi naught or work function is given with the unit of electron volt. Okay. If light is having a wavelength of 2800 Armstrong, what is it? If the light is having a wavelength of 2800 Armstrong falling on this potassium metal, find the kinetic energy of the electron volt of the most energetic electrons ejected. Okay, we need to find out the kinetic energy. How can we find out kinetic energy? Kinetic energy is equal to h nu minus phi naught. Here, phi naught is given in electron volt, so we can find out the energy of the incoming light also in electron volt. We can do the subtraction so that we'll get the kinetic energy also with the unit of electron volt. Okay. Phi naught is 2.3 with the minus sign I am writing. We need to find out this energy. Array, if the light is given in Armstrong, okay, I have given you a formula, right? How to find out the energy E? How to find out the energy E if wavelength of the value is given? I have told you. It is 12400 because wavelength is in Armstrong. How much is it? 2800. You will get the answer of energy in electron volt. How much it will come? 001240 by 280, almost 4.4, almost approximate something like that will come, right? Okay. So we'll write 4.4 minus 2.3. So this will come around how much? 2.1. Answer option B. देख ले. Else, if you didn't know this value of 1240, what do you have to do? H nu is equal to hc by lambda. You will get the energy in joules. You will have to convert that into electron volt by dividing it by 1.6 into 10 power minus 19. Very big task you will have to do. Okay, देख ले, भैया has saved you from all those problems. 12400 by 2800 आ जाएगा आपको आंसर एनर्जी पे, है ना? आ जाएगा आपको एनर्जी पे. कितना सुंदर चल रहा है सब, राइट? कितना सुंदर चल रहा है. Got it, honey? Sanskar, Anera, HRX. Very good. If you want to note it down, जल्दी note down कर ले. जल्दी फटाफट. So shall we proceed? Next question के लिए? ठीक है. Next question तो आ गया बच्चों. Next question तो आ गया. Got it, सर? Cool. ठंडा termy, cool. Go for it. A new concept is here. I'm going to explain that concept also. Okay? So first, what I need every one of you to do is here, read the question properly. Try to do it. Next 30 seconds of your time is to read the question and understand in your own way. फिर आ जाएगा आपका भैया. Then I'll start explaining. Go for it. हो गया? 15 seconds more you all have. Tick, tick. Okay, last 5 seconds. 4, 3, 2, 1. And who all are here with the correct answer? The first correct answer I can spot is from Rishabh Kashyap, which is the option A. Very good. Very good. It was option A, right? It was option A with 7750 Armstrong. Okay, so Evelyn also have given the option A right now. Now Shama is giving the option A now. Honey bhi de raha hai, Sena bhi de raha hai. Everyone is giving. Sumit is also giving. Very good. Okay, dekh le. How can we explain the concept here? The work function of a substance. ठीक है, एक substance का work function is 1.6 electron volt. Electron volt is not good. ठीक है, work function is 1.6 electron volt. Fine. Okay. The longest wavelength of light that can produce photo emission from the substance is. Sir, कैसे करेगा sir? What is this longest wavelength wala concept? You only have thought about that threshold frequency, that minimum frequency required. From where did this maximum or longest wavelength concept came, sir? Can you explain? Frequency is equal to C by lambda. And we know that photoelectric effect can only happen if there is a minimum value of frequency, right? There should be a minimum value of frequency for photoelectric effect to happen, है ना? ठीक है. So if the frequency is minimum, wavelength is inversely proportional. मतलब to have a minimum frequency, the wavelength should be having the maximum value क्योंकि it is inversely proportional. समझ में आ गया? So if wavelength is having a very large amount, ठीक है, then that photoelectrons will be emitted or photoelectric effect can happen. समझ में आ गया? मतलब if the frequency is having a minimum value or greater than that, photoelectric effect happened. But wavelength is opposite. If the wavelength is having a very higher value or lesser than that, क्योंकि as wavelength becomes lesser, frequency increases and energy increases. समझ में आ गया? Are you getting the concept now? So for having minimum frequency, the wavelength should be maximum, and that maximum wavelength is the question. How will we find out that? Okay. We know the equation to find out the energy in electron volt. What was it? It is 12400 divided by wavelength in nanometer Armstrong. That is equal to energy. And how much of energy has to be given for the electrons to get emitted? कितना देना है? 1.6 देना है. ठीक है, हो गई बात. इतना ही है. 12400 by lambda. We know that the basic equation is h nu, right? That is hc by lambda. This is the basic. But this is in joules. Then we have to convert to electron volt. Instead of doing all those work, we can simply write 12400 by lambda by calculating hc by lambda का value. ठीक है? वही कर रहा है मैं. And that is what is exactly done. So the wavelength in Armstrong is equal to lambda is equal to 12400 by 1.6. How much it will come? 7750 आ जाएगा. Option A आ जाएगा. ओके आ गया समझ सबको? आ गया समझ सबको? ओके नाउ टेल मी हाउ मेनी ऑफ यू आर गोइंग टू डू द रिविजन ऑफ ऑल दिस क्वेश्चन. कौन कौन करेगा रिविजन? Okay, how many of you are going to do the revision after this class? How many of you are like, sir, okay, we have learned a lot many things. सच में you have learned lot many things. Photoelectric effect का बात हो गया. Okay, so every one of you, Evelyn, Wage, Sana, Hani, okay, Anera, then we have Kushbu, Sanki, Rishabh, Sanskar, so, right? I want every one of you here to do the problems. ठीक है? Fine. Okay, ठीक है. So that is your vada because I'm going to give you one homework question here. Okay, एक homework question दे दूंगा. ये करके आजा. ठीक है? ये हमारा homework question है for tomorrow's class. So do this as homework for tomorrow's class. मतलब next class, right? Okay. Come with the answer. Let me see how many of you are going to be super, who's going to be super regular to the class and who really wanted to learn this chapter. One more thing, those who haven't liked the session, this is your time. Move the cursor and click on the like button. मेरा बच्चा लोग, ठीक है? Okay. Okay, side तो दे दिया. Side तो दे दिया. Okay. Fine. Sumit, yes. Okay. Now I think I have promised you a small Chotu Nannu Munnu song, है ना? ठीक है. उसका वक्त आ गया है, I suppose. छोटू वाला. ठीक है? एक song. And here we go with the song. Which one will we sing? ठीक है. दो दिल मिल रहे हैं, दो दिल मिल रही है, मगर चुपके दो दिल मिल रहे हैं, मगर चुपके सबको हो रही है, हाँ सबको हो रही है खबर, चुपके मिल रही है, मगर चुपके सांसों में बड़ी बेकरारी, आँखों में कहीं रत जगे, कभी खाने लग जाए दिल को, कभी फिर दिल ना लगे, जरा थम लूं जादू का मैं इसे नाम दूं, जादू कर रहा है, जादू कर रहा है असर, चुपके दो दिल मिल रहे हैं, मगर चुपके मगर चुपके Okay, fine, awesome. Sanskar, Abhilasha, Vipu, Naira, Sanki, Evelyn, Array, thank you so much. Thank you so much, everyone. Mithile, Sanskar, Sanki, okay, so amazing. Sana, Abhilasha, Naira, everyone, thank you so much. Thank you so much for the love and the care. And I hope that more than the song, you all have enjoyed the lecture. Okay, and this is your time to move the cursor, click on the like button and do let me know that you all have enjoyed the class, isn't it? Yes, this is the time. So go for it, go for the likes. Now let us wind up the session. Okay, thank you so much once again, TK, for all your wishes. Now tomorrow we have a special class, don't miss it. Okay, we'll be doing so many problems, whatever problems are left, Hannah, we'll be doing all those problems in tomorrow's class, don't miss it. ठीक है, it's on dual nature, मतलब this photoelectric effect के बारे में we are going to do lot many questions. Special class, as you all know, वो तो बहुत free है बच्चा लोग, it's completely free हमारा special class. Okay, it's completely free. Now those who don't know how to join special classes, I'll tell you. ठीक है, those who haven't used special classes before, you just have to download the Unacademy learning app. फिर then you have to log into the app. लॉग इन करने के बाद गो टू मेनू से क्लिक ऑन स्पेशल्स. ओके, फ्रॉम स्पेशल जस्ट गिव हमारा कोड, रेफरल कोड. दिस विल हेल्प यू टू गेट इनटू द स्पेशल क्लासेस फॉर फ्री. मेरा बच्चा लोग, इट्स कंप्लीटली फ्री, डोंट मिस योर चांस. फाइन. Republic Day special offer is going on, मेरा बच्चा लोग. It is only till tomorrow midnight. Because if you go for 12-month subscription, extra 6 months is given free, and don't miss it. Along with 10% of discount, to get the discount code is AMB10. Okay, fine. Moving on. Unacademy Prodigy program is happening. It's a scholarship test. If you want to get a scholarship for your college worth rupees 20 lakh, this is your chance. And if you want to enroll for the scholarship for free, you all know the code, right? It's AMB10. So don't miss this chance. The dates and time for each and every classes is being given here. Accordingly, you can write the exam. Okay? And the prizes along with the scholarship, they claim first rank MacBook Air, others Apple iPhone, iPad. Don't miss your chance. Fine. Moving on, special class ka timetable I already have update you. So thank you so much everyone. Once again, if you haven't liked, this is your time to show some love towards your bhaiya. Go and like the session, share the class to all your friends, and the notes will be available in Unacademy Class 11th and 12th Telegram channel. So bye everyone. See you all in the next class. Till then, bye bye.